Okay. So here we are just reading data by using pd.read CSV. Okay, as we saw in pandas. Okay. So another is data.head. As you know that how like top 5 rows of the data by using data.head we can read. So here let's see how our data looks like. Okay. Then the data.tell is the top bottom 5 rows. So data is like 7 to 5 2 number of rows are there. Okay. So data.info. This, as we know, gives the information about our data. Like there are 13 columns. Okay. Serial number, name, location, year, kilometers driven, fuel type, transmission, owner type, mileage, engine, power, seats, new price, and price. Okay, so these are total number of columns. These are their types, like either they are integer, object, float, whatever the values belong to that particular column. Okay, so as we saw yesterday, we check for the duplicates, right? So here, how we check for the duplicate value? Okay, so data dot n unique. So as you can see here, there are total number of rows are 7252. Okay, 7253. Serial number is 7253 means total number will be 7253. But you can see name. Sorry. Okay, so you can see the total. You can see here serial number are 7253. Okay, so the name are 2041 means the names are repeating. Okay, years is 23 means all other years are repeating. These are the unique value from that particular column. Okay, so for example, okay, no worries. So we will see one by one. So you can see year is 23 means only 23 unique values are there, and all other than 23 means 7253 all the are duplicates of it. Okay, or else you can see all other values are repeating. Okay, so as usual, we find null values like data.isNull.sum. So here it will give you the number of null values. So 46 null values are there in engine, 46 null values in power column, right? So here the another function we are using by using isNull.sum. This is the length of your data into 100. Okay, this will give you the percentage of missing value in that particular column. So you can see in the new price 6247 number of null values are there means that it is 87% of that null missing values. Okay, so you can directly see here if 86% are the missing values, so you can directly like drop. Okay, so it helps you to take that particular column or to drop it. Okay, it helps you to take your decision. So now data reduction part is there. Okay, so you can see the serial number. Okay, everything which I need to write I have already written here. Okay, in your data set the column S number have only ID values, right? So assuming they don't have any predictive power to predict the dependent variables, okay, so that we can skip it. Okay, what before applying everything, what we have to do is we can just remove or we can just delete some number of columns which are not so important. So here serial number column is not so important, which will not help us to predict the price, right? Or which is not going to affect the price of our car. So we can delete it. So here just by using dot drop, we can drop that particular column. So here serial number is there in previous. So in the new info, serial number is not there. Only the name column is there. Okay. Up to this, everyone is clear?
Yes, ma'am.
Yes, ma'am.
You can comment also, okay, in chat section so that I can get you. So the next part is feature engineering. Okay. So the main goal of feature engineering is to create meaningful data from raw data. So as I told you, feature is nothing but the most useful column of your input data which directly affect your output. Okay, so here let's start. See, it would be difficult to find the car's age if it is in the year format, as the age of the car is the contributing factor to the car price, right? So we know that car age is matters to the car price. Okay, so I don't know that means old car are more means I don't know about that price so much. So anyone knows that if the car is older, then its price is high or low?
Low.
Okay, so older the car, lower the
Mummy,
price.
बोलो मत अभी.
Is it? Hello. So if
Yes, ma'am. If the car is older and kilometers are more, then the price will be low.
okay, okay, so older the car, price will drop. Okay, so here we can see in the year we are already given year. Year column is there, and another column is what? No, only year is there. Okay, so from the year column we can find that how old that car is. Okay, so here we are generating the new column name with car age, where date dot today means we are today dot year means from the today's year we are subtracting that previous data of that year so that we can get the car age. So here you can see at the end, let me see it to you. This is the new column with the car age, and yes, from you can see today's year is just wait. Okay, so this is 2022. Okay, assume it. So if you subtract 2022 minus 2010, so the output is 12, right? Likewise, everything. You are just subtracting this today's year, means you are subtracting this all data from this data, and respectively you are getting these all the output. Okay. The next one is, since the car names will not be the great predictors of the price in our current data, let's split the name and introduce the new variables brand and model. Okay, so you can see this is the name. Okay, so the name of car, that doesn't matter so much, but what we exactly want is the brand name of that car and the model, right? So how can we distribute this name? So we are first column we are creating as a brand, where we are taking the data from the name column. Okay, as we know that the data type of the name column is object, so name dot string. We are splitting the name column, and we are getting the 0. 0 means the first word. Okay, so if it is this is, for example, this is the Maruti Wagon-R, right? So this is your 0, this is your 1, this is your 2. So we are taking the only 0 means only the name of, oops, sorry, only the name of this Maruti. The second one from here we are taking just Hyundai. The second is 0 means Honda only. Okay. Likewise, we are taking only the 0th value of that string. This is how the data splitting works. And then the second model, okay, we are taking the first value plus second. Okay. So our output looks like, if we extract only the name, brand name, and model column. So this is how our output looks like. Okay. So here are the name. This is your brand, and this is your model number, or you can say the model. Okay. So the next up to this, everything is clear up to this.
Yes, ma'am.
Yes, ma'am. Yes, sir.
I hope you are getting right, and this information is useful for you. I hope. Okay. So the next is data cleaning. So the how to clean, as yesterday we discussed what is the data cleaning. Okay. So this is print data brand unique. Okay. So these are the all your brand name, means all unique brand names. So as you can see here, okay. You can see here, or else you can see here the total number of rows, right? 7253 number of rows there, out of which 33 are the unique values or unique name, means only 33 brands are there. But in here, some are like repeating, like this. You can see these names are repeating. Okay, so it is in small letter, it is in capital. Okay. So this mini also there, and somewhere it is land. Okay. So here what we are doing, we are like extracting all the data for that particular names. Okay, so all the data having this means is this small, this capital, this mini, and this land word will extract here. Okay. Can you see this is all this brand? Okay. So this is all the data having their brand name with these all 4 names. And then we are taking the top 5, means we are just concatenate them with search for. Okay. So what we are doing here, in the table brand, replace this big, this capital Isuzu with the small. Replace this only mini with the Mini Cooper. Replace that land with Land Rover. Okay. So in place equals to true. So here we are replacing all the values. Okay, which are similar. So if we see the brand unique again, let's see what's the output. See, it is 32. So this Isuzu got replaced. Yes. So the next is data describe. So I hope you are like, you understand what is the data describe. Okay. This gives you the count, total count, mean value of that particular, and it works only with the numerical values. Okay. Means only with the columns having the float and integer values. Standard deviation, it's mean 25th. This is nothing but your interquartile range. This. Okay. IQR, you can see. IQR. My mouse is not working. Okay. So another. Okay. Another interesting thing is, if you want to put this all in the table, just write .t in front of your describe, and you will get all the data in the table form. So you were like, this is your vertical things will got arranged in particular table horizontally. Okay. So just by writing T, you will get. And if you, this is only for describe, means it will only give the numerical value. Okay. And if you want to describe all the data, you can just write include all, and you will get information for all the data. Okay. So next one.
Ma'am,
Yes.
excuse me, ma'am. Dot T is a table or a transpose? Transpose.
Actually, the dot is we are using just to, you can say transpose as well. We are just using it to like to move it like horizontal, right? This is your vertical from and this is your horizontal. So table is
Okay, ma'am.
horizontal, right?
Okay.
You can say like matrix transpose. Yes, you can say it.
Okay. Thank you, ma'am.
Okay, and if you want to find your numerical and categorical value, so here we are using this categorical columns. Okay, so if we data dot select d types include object. So by using this, only object values means column having only object values which comes under the cat underscore columns means categorical columns. Okay, guys, if meeting ends in 10 minutes, please join again. Okay, and data dot select d types includes np dot number. Okay, the columns having the numbers will comes under your numerical variables. Okay, so for cat calls we are printing categorical variables, and for num calls we are printing numerical variables. So you can get which are your categorical and which are your numerical variable directly. Okay, so clear up to this?
Yes, ma'am.
Yes, ma'am.
Getting the points, understanding the points?
Yes, ma'am.
Okay, describe is used to show, yes, Ibrahima, describe is used to show statistical information about the numerical values of the data set, right? Okay, so next is EDA univariate analysis. As we saw yesterday, we use univariate analysis to perform it on individual columns, right? With using individual means one single variable. Okay, so here we are using that skewness of the data means like which side it is skewed. Okay, so for columns in the num underscore col, so for all numerical columns we are using this, we are printing its skewness. Okay, so skewness, let me explain you. See, you can see this, for example, this is your data. Okay, if the data is like this, you can say this is skewed this side. Okay, means towards x-axis. No, towards positive. It is positive. Yes, this is positive skewed because the data is skewed to right side. Okay, and if this is this side, we can see it is negative side. Okay, so negatively skewed data. So let's start. So the all other things are nothing but the PLT dot figure size. This is the figure size. You can change it. Okay, so if I change this to 10, I'll get the output in the reduced size. Okay, so you can change it. If I write it 15, whatever you can change. So that is just simple figure size. And next is subplot. Subplot is 1 to 1 means
Ma'am,
yes.
ma'am, what is the meaning of 2 after that skew? In the second line.
Okay. Just wait. Yeah, it came the same. Round data column skew, comma 2. Actually, we are using it at print, so we can just use.
Ma'am, it's like we are up. We are getting the value of skewness up to 2 decimal places.
Maybe because at the output we are getting it. Let me check.
It's like a square.
I don't know exactly. Let me check first. Yes, actually, because see, if you use only that, then only -1 is given. Okay, so let me check. Yes, it is giving decimal only after writing here more than 2. Okay, what if 1? Yes, it is for decimal value. Yes, it is for decimal value. Okay, so here you are directly getting it is negatively skewed or positively skewed, right? Okay. All of that things are nothing but your PLT dot Y label, X label, subplot. Subplot is nothing but this how you divided your plots. Like this is your 1 row and 2 columns. Likewise, you can distribute it. Just you have to do your figure size small. In MATLAB, this subplot concept is there. Okay, so this is your simple bar plot. And this is your viscous plot, or you can say box plot, where as I told you previously, that max minimum 25th percentile, 50 percentile, 75th percentile comes under all this category. Okay, either you can find it by using the describe, or you can find it by visualization using this box plot. So this dot 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 are nothing but your outliers. Okay, which are which shows that these values are far away from your all data, right? So the next is categorical values using count plot. So we are using this count plot for the categorical values. This is nothing but your simple bar plot. Okay. So figure access plot. Actually, this all information you will find on. I'll suggest you one site. I think it's learn, where you will get the meaning of that each argument. Okay. So let me check it, or else I'll send it on group, where you will get all the parameters. I think it's echelon. No, it is scikit-learn. Yes. On the scikit-learn, you will find the everything. Okay. So meaning of each and every parameter. So here we are using SNS, as we already import the library at the initial only. This is C1, which imported as SNS. So we use it for plotting. Okay. So this count plot we are using from this C1 library. Okay. So this count plot is nothing but you giving you for your categorical values. So the diesel price, the diesel and its count. So petrol your count. So this is all about categorical analysis. And in bivariate analysis, as I told you, bivariate is nothing but the comparison of two variables. Okay, so here this is the comparison of two variables. For example, this is your car age, this is your year, this is your seats, this is your year. Okay, so I'll explain this how it works. Okay, so this is called the pair plot. So this pair plot is plotted between the kilometer driven and price. Okay, so let's see how it looks like. Kilometer driven and price. So if the price kilometer driven is more, price should be less, right? So this is nothing but your year. Okay, so as year increases, the seat column should not be there actually. Okay. Mm, just wait. Let me check with this exact. What is this exactly?